Good morning, one and all, to another edition of Finzics. This is Mr. Finn coming to you live, well, actually recorded from my home in Northville, Michigan. Hey, a couple of things today. We have our last video for this particular time frame. We're going on break, so the next video will commence on April 5th. So appreciate you guys for checking in. I really do appreciate the views. Make sure you guys get a chance to review all of the information that you've had over the last 2 weeks. Also apologize to everyone for my editing blurbs. I've been trying to edit some videos. I made some colossal editing mistakes earlier on in the process. I think I've got that all worked out. So from yesterday's video on forward, I think the editing should be a lot better. I do apologize for that. A little bit of a slow learner here on the online learning strategies. A couple other things. Today is our Google form, so I'm going to go a little bit lighter today on our video review of the topics for the Ohm's Law section. I'm going to go a little lighter, just review some of the main concepts, give you guys a chance to do your Google form, and then that should be enough. I'm going to hold off on another circuit example until the April 5th time. Speaking of circuits, there was a question yesterday about do we have to know the difference between series and parallel circuits? The answer is no, not at this time, because that is the subject of Chapter 35. So Chapter 35 will begin in earnest on April 5th. And in truth, this is really just keeping tabs on the information that we would have had in class. Now, if we end up coming back to school in mid to late April, then all of this material will be subject to optional credit. So just optional credit moving forward, and then we'll hit with waves when we come back, or I'm sorry, we'll hit with electromagnetic induction and magnetism when we come back. But otherwise, I'm just going to keep going so that you guys have the opportunity to finish your physics education, your credit, test out of the class should you need to have that happen. Okay? All right. So, circuits are not on the Google form today, and the Google form will start at 10 a.m. Will be available for a few hours there. I think until 2. I'm going to try to get back out to 2:30. And then your videos will resume on April 5th. So that's really the only announcements we have today. There were no questions through email, so I'm just going to get started on the review. We're going to go to our magic board here. Okay, guys, I'm back. Here's a little bit of a kind of a visual review. Maybe just take a look at some of the bigger concepts we've had through the Ohm's Law section. Of course, we're going to start with the definition of resistance. Resistance, remember, for any wire or any material is going to be greater if the item is longer. So if you had a longer cord, the resistance would be greater. Similarly, the resistance would be lower if you have a thicker wire or a thicker material to move through. Okay? What is rho? Rho is that constant of resistivity. Now we don't have to do too much with that, but it's helpful to know the relationships. So if I had 2 extension cords hooked on together, then a drill or something that I operate on the end of those extension cords might move with a little less of the power. Power reaching the end might be a little less. Why would that be? Because the current would be less, because the resistance would be more. Let's move over here to Ohm's Law. Ohm's Law, the relationship between voltage, current, and resistance. Now remember, we can solve for any variable if we know the other two. Ohm's Law, voltage equals current times resistance. V equals IR. Much the same way that F equaled MA way back in Newton's laws. Similar to that, power is equal to current times voltage. So I mentioned just a moment ago, if you had those 2 extension cords, well, then what would happen? Your current would be down, your voltage would be the same. Why would your current be down? Because according to Ohm's Law, current goes down when resistance goes up with the same voltage. So if your current goes down and you have the same voltage, then your power at the end of that cord would be less. Okay, Other ways to look at power. If we rearrange the variables, see my video on power. V squared divided by R is another way of expressing that. And of course, I squared times R is another way of describing that. So any of those three guys would work, and you can shortcut, maybe do a solution in one step rather than two steps if you have those quantities. Speed of electrons in the circuit. Remember, we talked about that very early on in this section. We're talking about the difference between two different circuits here. In a DC circuit, so a DC circuit is one that has a battery or some kind of direct current supply. That's what DC stands for, is direct current. So, a battery supplies direct current. Now, what happens to that is you have electrons bouncing into other electrons. So the electrons actually move or migrate very slowly from the negative end all the way to the positive end to neutralize this battery and make it useless. But during that time, the electron energy flows at the speed of light. Speed of light for energy, and electrons move very, very slowly, on the order of about 0.01 centimeters per second. So it would take several hours for your electrons to travel about 1 meter. And that makes sense, because if I took my lights on in my car and I just turned my lights on and sat there with the radio playing and the engine not running, my car battery would last several hours before it died out. In AC circuits, electrons don't do that at all. They simply bounce back and forth. They jiggle back and forth, and they stay in the same place. So, the light bulbs that light when plugged into an outlet, like a lamp, for example, those electrons that light the bulb actually come from the light bulb itself. They don't actually go anywhere. In AC circuits, we just get it oscillating back and forth. Still, the energy goes to the speed of light. So both in AC and DC, the electron energy goes at the speed of light, but in AC circuits, the electrons simply jiggle back and forth and don't actually move anywhere. Lastly, something that we didn't quite cover, and this will be our subject for today, the definition of current. You can define it as voltage divided by resistance according to Ohm's law, or you can divide it or define it by its actual definition, which is the amount of coulombs that flow through an area per unit of time. So, how many coulombs flowing through a certain area in a certain amount of time? So that's flow of charge per time. And we're going to call that current in amps. Measured in amps. So that's it, guys. There's not too much more. You might want to read up a little bit on the role of capacitors in circuits and diodes. All that is just smoothing out the current that you would get from an AC circuit. So you can use a diode, which is basically a one-way gate, and a capacitor to smooth out the charge that you get from converting from AC power to DC power. So it can be done. Okay, guys, that's it. We'll wrap up and send you on your way here for spring break. Okay, guys, I hope that was helpful. I hope you got the review on Ohm's law, power, speed of electrons in the circuit, definition of resistance and how it plays out, the difference between AC and DC power, and maybe the definition of current. Obviously, if you got a chance to look over maybe how to smooth out power using diodes and capacitors, that'd be great too. That's the extent of the entire section. I did want to talk about my hat today, and a lot of you guys are making comments on my hats I've been wearing. Mostly I wear something Farmington related. Obviously for St. Patrick's Day, I used my St. Patty's Day hat. Today I'm wearing my U.S. Open hat from 1985. Now why the U.S. Open hat? Well, I'm really hoping that those golf courses can get open at some point so I can play a little golf. You never know. With some decent weather and nothing else to do around here, I'm going to teach you guys physics and do yard work. I think I'd like to get around to golfing every once in a while. I hope you guys are having a great day. I hope you have a great break. Remember to get a chance to do that Google form. Just test yourself every day. It's a good way to stay sharp, and of course we want to make sure that we're able to have the requisite knowledge of physics. If there's anything I can help you with, as always, please send your questions through email, and I'll address them on the next video. We'll see you guys April 5th. Have a great break.